You to the Silicon Valley Naga Professionals speaker series. Today, our invited guest speaker is Atman Brahmachari. Welcome. I wanted to give a few minutes of introduction to Atman Bhai. Atman Bhai is not only a member of SVNA, but we are very proud of him because he has over 20 years of experience in the field that he's going to be discussing today. And because it's such a vibrant topic of data science, I knew that right from the start, I wanted Atman Bhai to come to give us time and take us through all the intricacies and the details of what is data science. Atman Bhai is a data engineer at Standard Cognition at present. He has been a data engineer at LinkedIn, and he's been the data lead, tech lead, big data warehousing lead, data engineer, cloud platform lead. All these, the hats that he wears and has worn for the last 20 years actually identify this field. So he has been in the thick and throes of the big data. What I can say is, from whatever I've read and heard about data science, is that it's related to that part of science which focuses on the applications of data and how it's collected, how it's analyzed, how it's monitored, how it's used. And there is a whole world out there which needs to be understood because it's the most vital field from now. I wanted to take you through just one or two very important quotes about data science before I hand it over to Atman Bhai to explain to us what they all mean. The first and most catchy quote that I came across was, "Harness the power of data." That's what data science is. The other one was, because I use his virus software, was written by Andrew McAfee. It is, "The world is one big data problem." Another quote is, "Data is the new science. Big data holds the answers." Data is a precious thing. This was written by the person who invented World Wide Web. Data is a precious thing and will survive beyond everything else. And the final quote that I found most appealing was written by a professor of science, and his name was Dr. Edwards Deming. And he said, "In God we trust. All others must bring data." And I thought that was the most endearing of them all. And with this, my brief introduction to Atman Bhai is ending, and I would like to welcome Atman Bhai to our platform. Please enlighten us. Thank you.
Yeah, let me first share my screen and then we'll go from there. Are you able to see my screen now?
Yes, we do.
All right, very good. Yeah, so Jai Hatkesh, everybody. Like Sharvari said, I'm Atman Brahmachari. I have been in the data field for many, many years and have worn various hats in the form of data, like data warehousing lead, DBA, that is database administrator, and a big data engineer and data scientist and things like that. So various things in data. First of all, I'd like to thank SVNA, the committee, Kinjalben, Sharvari for giving me this opportunity to share my knowledge with our own Nagar community members. And secondly, the audience itself, thank you for attending the session today. I will now start on data science. Data is basically information. Any information that we know, that we collect, that we share with others, it can all become data. There is subtle difference, or data can be said to be information that is more structured, more organized, maybe more meaningful, and so on. So if you think of the 20th century, at the beginning of the 20th century, people started inventing, vehicles and all. And soon they realized oil is something that will bring unprecedented motion in this world. That is, people can move from one place to another much more rapidly than they used to be able to do in the past. So it was a transforming invention. I mean, oil was always available, but like its use was a transforming invention, we can call. And the same analogy applies now in the 21st century. Information is so important. It's key to all the businesses today, not just in America, but all over the world. And only the 20 years of this century have passed so far, but this statement, in my opinion, and in most people that are in this industry, in their opinion, it applies to the remaining 80 years of this century as well. So information is so much important, and that's why even Hal Varian, the economist at Google, he once said in his lecture that even war is 90% information. That's because we can develop new weapons in terms of, talking in terms of war, we can develop new weapons, we can develop new strategies, but without information about what we are as a country, what our strengths are and what our weaknesses are, and what our enemies' strengths are and weaknesses are, without that knowledge, without that information, all strategies and all weapons can prove to be useless. And that's why he rightly said that war is 90% information and only the rest of the 10% is other things. So that much is the importance of information, and in other words, that much is the importance of data as well. So today that we are going to talk data science, we will talk about what it is, how much important it is, and how beneficial it is, and how we can pursue our career in this field. So let's start with that. I'll first give you a brief overview of data science. So data science is about, first of all, collecting data. You need to have data and you have to collect it from various sources from where the data is coming. So we have to collect it, then we have to cleanse it. Cleanse is a specific term in software engineering. It's largely about actually cleaning the data, that is removing unwanted data and keeping only the data that is useful to you. Mining is about going deep into the data, understanding any kind of patterns in the data, or extracting information that was not otherwise visible to you, and so on. Sometimes we say read between the lines, right? It's like that. When you have some data, you go deep into it, study it, and extract some more important information out of it. So that's mining. And machine learning is the next step, where you teach machines. It's like you give them, machines or the computers, some information, give more information, and then tell the machine, hey, can you now predict what is this new information? And then machine with some accuracy will be able to predict what this new information is about. So that's what is called machine learning. I'm going to talk a little bit more about it in the later slides, but yeah, that's that. And once the machines are able to learn like that, and they are able to predict the future. So that's where this whole trend of data science is. That data science and its sub branch called machine learning, it helps predict things in the future in terms of business needs and so on. And that's why governments, business entities, and every single person on this earth is going to need data science at their core. That's that much data science is important in this world today. Talking about the ecosystem of data science, as you see here, we have at the center something called data engineering, and then we have these data sources. So data may be existing on the internet, for example. Think of you typing some search keywords on Google search, and the information comes in front of you, right? That information actually resides somewhere on the internet, on somebody's website, but it is brought to you, right? So in that sense, we can say that the data resides on the internet, right? Sometimes data resides on the data centers of big companies or the cloud platforms, if you have heard of that term. If not, don't worry, we might briefly touch upon it later in the slides. But yeah, it might reside with the clusters of computers owned by some companies, or data may be existing with your business vendors or business partners and all, and you need some of that data for your own analysis and so on. So here at the center, we have this thing called data engineering. Data engineering is about collecting data from various sources, then cleansing it, that is, removing any unwanted data, and then organizing it and like transforming it into the format that your customers need, and then persisting it, meaning, saving it somewhere so it can be used anywhere, anytime, anywhere that we want. Also keeping the data secure, that is, nowadays we have heard of hacks and ransomware and things like that, right? So we have to protect our data. So all those things are done by data engineers or the data engineering divisions of companies. And in that sense, that also is a very challenging field. It requires complex architecture, huge architecture, high scale management of data and so on. And that's also a very interesting field. In my current role, I am actually working as a data engineer, but I also have knowledge about data science and all. So now, if you have collected data like this, then you want to pass your data to the groups or the teams that require your data. And those teams could be, the data science teams or data analysis teams, product analysis teams, and so on. Specifically talking about data science, once the data is available to data science, how they are going to use that data, that's what is explained here. That, like I mentioned earlier, they cleanse the data. Cleanse in the sense, they got a bunch of data, a lot of data, but then they want only some of that data, or they do not want particular pieces of data, but other pieces of data, and so on. So they would clean the data in that sense, remove unwanted data and keep only the required data. Then they would do the data mining, which is like, understanding data in more detail. It's a small components and so on. And accordingly, they will try to extract some meaningful purposes out of that data, or the extract value out of that data really. And after that, the machine learning will happen, which is about teaching machines to understand that data, more data, and finally asking machines to predict what the new data is about. What is this new data about? So that is all like, machine learning and prediction, automation, and so on. Let's take an example. So everybody knows this is a Facebook page of our SVNA, some activity from the past. And mind well that this example is specific to Facebook, but many different companies, thousands of companies are using data for their own business purposes. Our focus will be on this example for now. So as you see here, there are so many pieces of information residing here. For example, here we have so many member profiles that we can click on and see the member profile data. If you click on events, you get to see what events are coming up and so on, media, event topics, any discussions and all. You see that there is some video that was being played here. You can watch the video, you can pause the video, you can resume the video, like things, comment things, you can join some groups, or you can invite people to join groups. This is just a handful of a large number of things that you can do on this on a Facebook page. Now, the thing is, Facebook captures every single activity that you do on this page. That is, if you click and see member data, they capture that information. If you like somebody's post, if you comment on a post, Facebook captures all that information. If you invite somebody, they capture that information. Not just that they capture that information, but they also capture related information. For example, when you did that activity, at what precise time you did that activity. They also capture things like, you know, from which device, or like an iPhone or a desktop or an Android phone, or which device you used to do this activity, or which city you were in. Were you in San Francisco? Were you in Melbourne? Where you were, you know, it captures all that information. The purpose for capturing all this information for Facebook is twofold. Number one is that if Facebook knows what you do more, what you like more, and what you enjoy more, then it can provide relevant feeds more and more to you. So you continue to enjoy the Facebook platform and you become loyal to Facebook. That is the first goal. The second goal is that now that, you know, Facebook knows what you like, what you do, when you do things, and much more, that it can share this information in a lawful manner, obviously, but share that information with advertisers or in an automated fashion. And it uses that information to show ads to you that are more relevant to you. And when they show ads, they make money out of it. I mean, I don't know whether you guys know this, but just in the last year, 2020, Facebook made $86 billion of revenue, 86 billion. That's because Facebook has more than 2 billion users all over the world, and every single minute of the entire year, they capture every piece of information that flows on their platform, like clicks and comments and all that we just talked about, right? So they gather so much of information. Now, just imagine that capturing so much of information from 2 billion people and several clicks and all. That's like trillions and gazillion pieces of data that flows from your browser and other people's browsers into the Facebook servers. Managing this whole network of data flowing, the whole pipeline of data flowing from your browser into their servers, and managing and organizing that data and all, that is a very challenging task. And that's where these data engineers and data scientists, you know, play their role. I talked about advertisements. So like, you know, just a few weeks ago, or maybe 2-3 months ago, I was trying to refinance my home, and from my online activities, Facebook learned about it, and it showed this ad to me about refinancing and all. So like I said, you know, they make money out of it, and tons of money. And that's where, you know, data science and data engineering are very critical to their businesses. So like I said, you know, they collect data, they collect timestamps when you did some activity. Even when you scroll down, you know, they capture that information as to how far deep a user scrolled down the Facebook page, where you clicked, location, device, and all that I talked about. And then, you know, as part of this data science, not only that you do data collection, but you also do cleansing. Sometimes, you know, people are inactive on Facebook, some people pass away and their data is meaningless. So they have to remove that data and things like that, even outliers and so on. And once you have the right data in place, then you want to, you know, dive deep into it. You want to figure out, like, you know, the topics a particular user spends more time on, or the topics that a user clicks the like button on, and like the videos that you watch, whether you watch the video in full or half, because that way they understand whether you like the video and how much you like the video, up to what portion you like the video, and from what point on the video became boring for you. They want to gather all that information, and that's the data that we are talking about here. So like mining of that data happens. And then comes machine learning. Understanding machine learning is, at least at a high level, very easy. let's take the human analogy. So think of a very small child who doesn't even know the name dog, but a parent shows a picture of a dog and says, see beta, this is a dog. And 2 days later, the parent shows maybe, a real dog and says, see, this is a dog. And then shows another picture of a dog, maybe 2-3 days later and says, see beta, this is a dog. Now, our God, our Hatkeshwar Dada has made our brains such that we learn from what we saw, what we heard, and what we felt. We learn from that. So what happens is that this child saw these 3 pictures or maybe a real dog and so on. And the next time when the child sees a similar picture or a similar moving creature that has, very similar characteristics like 4 legs and a tail and 2 ears and 2 eyes and a tongue hanging out and barking and all, the child immediately predicts that this is a dog. So this is how the human brain works at a high level, right? There is a lot of intricacies to that, but at a high level, this is what a human brain works on. I mean, this is how it works. And machine learning is also about this, that you give the machine information. You show the machine an image of a dog, and then you feed more images of dogs and more, maybe thousands of images of dogs you give to the machine, and then you write some program, write some code through which the machine understands the characteristics of the images that you have shown to it, the images of dogs that you have shown to it, and based on that, the machine is able to predict any new image to be a dog or not a dog. Do you follow me? Yeah. So that is what machine learning is, and it is definitely part of data science. I mean, there are deeper things like, setting assumptions. I mean, if you think of, more structured way of running your data science work, then it involves hypothesis, assumptions, investigation, like I mentioned here, even finding anomalies and all, pattern recognition and all. As you see here, some pattern examples. This is just a sample, but yeah, pattern recognition and all, it's all part of this machine learning exercise through which we teach machines to understand this historical data, understand the characteristics of that data, and based on that, be able to predict. Machine learning also consists of very common concept in machine learning called clustering and classification. Clustering is about, creating groups of, say in this example, like you have a mix of birds and animals, but in clustering, you see that, all the birds have been clustered into one and all animals have been clustered into another group. Whereas classification is about putting some labels like, this is a particular bird, whereas this is a particular animal, some other bird, some other animal, and so on, right? So you put specific labels like this is a peacock or this is a rabbit or whatever, right? So things like that. So it's a very deep subject. We are not talking it right now, but it's a very interesting subject. And with this machine learning, with this data science, with all the historical data, statistical modeling and all, companies nowadays are working to predict for something totally new. So think of these, like, Uber has its business in many cities, but if Uber wants to start their business in a totally new city, then with machine learning and with data science, they can predict how their business will be in that city with a high accuracy. So similarly, like if Amazon wants to start a new product, they can also predict with high accuracy. Of course, it requires a good amount of data and good machine learning training model for the machines and all. And those training models, humans, the data scientists or the data science engineers have to write those. But if you write those good models, you can have the machines predict something really with high accuracy. So things like that. So now that we know what data science is at a high level, another important thing to know, especially for those who really want to build their career in data science, know that, you will get to work on the cutting edge and latest technologies in software engineering. The programming languages that are listed here, like, Python and R programming, Java, Scala, and so on. Those are like the latest and most important programming languages in this data science field. So you will be using those languages for your programs. Not only that, but there are platforms available, like, the Amazon Web Services, the AWS platform, Google Cloud platform, or Microsoft's Azure platform. You will get to use those platforms and learn about those. You will also get to work on big data technology platforms. Many of you must have heard the term big data. So the big data technology platforms like, Hadoop, Spark, even the machine learning tools such as TensorFlow, Keras, and all, you will get to work on those using those platforms and tools and all. Now the thing is, we learned what data science is, but it's also important to understand what data science is not really. So for example, if you see some nice, beautiful web pages that you fall in love of, that's not data science. That's about web development. If you see powerful chips in iPhones, or some very micro circuits somewhere on a circuit board, that's not data science. If you talk about IT, many people talk about a general term called IT, information technology. Yeah, IT is an umbrella term to a great extent, but IT doesn't specifically say it's data science. Data science, so if you think of IT in general, it's about working on the available information and just organizing it and exposing it to its users, or making it available to its users. But it doesn't necessarily require deep scientific methodologies, whereas data science is probably 2-3 steps ahead of it. It is more about, scientific research-driven approaches to develop software that extracts out information from the available data that otherwise you would not have been able to extract. So that's why data science is 2 or 3 steps ahead of normal IT work. Now that we know about data science, you might have you might want to ask, like, how to become a data scientist. So just like it says, charity begins at home. Data science begins at high school, we can say. When you are in your high school, you certainly want to pay attention to mathematics and primarily algebra and calculus, plus also statistics. And nowadays, computer programming is taught in high schools. So please don't think that, I will learn it in my college. I don't want to do it now. No, you want to do it right in your high school. And that's one thing, but there is another aspect, generally stay in touch with mathematics. And that one way to do that is, solving mathematical puzzles. I mean, I have my younger son here. So I and he sometimes, visit this channel called Mind Your Decisions from Presh Talwalkar. On that channel, some small middle school to high school level problems, mathematical problems like, algebra and geometry problems are placed, like puzzles and all. And we try to solve those puzzles. And that's how we develop interest in mathematics. So that's very important at the high school level. And then when you go to colleges, there are various degrees offered by many universities in America. Those degrees may be called computer science, data science, statistics and data science, and so on. I would say that computer science is the most well-represented degree, because it covers a lot of different concepts of computer science in general, including machine learning, data science, and all. So I would prefer that one gets a Bachelor's of Science degree in computer science. There is also a degree called Bachelor's of Arts in computer science. That degree is also okay, preferred BS. Of course, you need to be good at linear algebra, calculus, and so on. There are other degrees, like I said, data science and all, statistics and data science. They may not be well versed, diverse enough to cover various aspects of computer science, but they may still be focused on data science. So that's also, so if you don't get into computer science, for example, then you should surely take the data science degree or any similar degrees from any universities in America. If you are living abroad, like in India, then you can surely consider computer science BTech or BE. Even if you do bachelor's of science, say you didn't get admission to engineering, but if you get bachelor's of science with math or statistics, you are at par with BTech or BE engineers as far as data science goes, because your fundamentals would be strong in math or stats, and that would be excellent. So don't get disappointed even if you don't get a BTech admission, but instead you get a BSc admission. You are still there in line for data science. Those who are transitioning from other fields, yes, you can do it, but like I mentioned, your math and stats fundamentals should be strong. Otherwise, you will find it somewhat hard to cope with it. Aside from the degrees, you can take courses. Fresh engineers, even transitioning people, they can take courses. There are different online institutes or online course platforms are available. Like Coursera is the most popular one. They have got excellent professors on their courses. Their courses are very well structured, very nicely designed over multiple weeks. They have quizzes and tests. They have a good scoring system, and they provide certificates that are verifiable, and that can be placed on your LinkedIn profile, so everybody knows that you have a valid course in data science. LinkedIn, which is the professional network portal, that also has its own learning branch called LinkedIn Learning, and they also have some courses and all. Aside from that, there are other video courses on Udemy and Udacity as well. These courses typically run from 4 months to 18 months, depending on what your background is. Various courses are available, but the one on Coursera, Data Science Specialization, that one is an awesome course. It runs through several months. Actually, it could run over probably anywhere from 4 to 8 months, but it is very comprehensive. And don't think that if you know little about computer science or programming, you cannot learn. You can still learn if your math fundamentals are strong and you know the basics of programming. It's a very comprehensive course. Other courses are also available that you can consider for data science. And once you have gone through these courses, got a degree and all, you can work for either big tech companies or other non-tech companies or startups and so on. Big tech companies, they have immense amount of data, a variety of data and all. So you gain a lot of good experience with data in terms of technologies. And there are many smart engineers, really world's best engineers with big tech companies. So you get exposed to those people. You have got, you are surrounded by smart engineers. Of course, those companies pay well too, but it may not be very easy to get into those companies. You have to work hard. Typically, it takes 3 to 6 months to prepare for such interviews. If you cannot get into big tech companies, and when I said big tech, it means the Bay Area companies like Google and Amazon, Microsoft, Facebook, Netflix, companies like that. If you can't get into those, you can try mid-sized technology companies or non-tech companies like financial industry, for example, Goldman Sachs or JP Morgan Chase or Wells Fargo, or even other like healthcare industries and all. They also need engineers and scientists to work on data. So it may be a little bit easier to get into those jobs. You can try that as well. And the third type of companies is the startup companies. It's relatively easier to get into startup companies. because they want smart people, but not necessarily, those who, not necessarily those who are very well experienced. So sometimes, even fresh graduates are consumed by those startup companies. And with the startup companies, their budget is low, their data volume is low because, they are just starting. They don't really have a large user base yet, maybe. So sometimes, you also start with a small scale of data, small scale of technologies and all. But the advantage with startups is twofold. Number one is that if the startup really grows, then you have an opportunity to start from really small and expand your design, your architecture and all to a medium level, to a very big or a huge level over several years. And that experience is considered great in the industry. With that experience, if you go out to some other companies, you will certainly win. That's one. And the second advantage is that if the startup really does well and grows big, then it might be acquired or it may go IPO, and that's a windfall. You make a lot of dollars, but not necessarily every startup will go IPO. So don't be over hopeful. I mean, if you really want to build your career in data science, obviously you should read magazines, blogs, etc., that are about data science, right? So the LinkedIn website has engineering blogs from companies like Google, Facebook, and Apple, Netflix, and all. Those blogs are about their large scale architecture, large challenges about data science and all, and how they solve or address those challenges and all. So if you read that, it doesn't necessarily require deep knowledge of data science, but it keeps you with it. You stay connected with data science and you feel good about, thinking about a career in data science. So please, do read those articles and blogs. Compensation and all, big tech companies, like I said, they pay really well. They have base salary, bonuses, stock options or equity, as we call it, employee stock purchase plan, retirement benefits, perks like free food and all, commute by company shuttle, swags, and so many things. There are many perks from these companies. So you will never regret joining these companies. In fact, you will be very happy. How to grow in this career? Is there a good career that you can build here? Yes, there are two paths, individual contributor path and manager path. If you are an individual contributor, you have to demonstrate your technical and architectural knowledge and experience and skills and all. As a junior engineer, you start with small tasks, building machine learning models, or junior data scientist. As you grow senior, you own a project that consists of several small tasks and all. You work with different teams. You make sure that your project uses best practices in the industry and so on. As you further grow and become a principal engineer, for example, then you design all the pieces of your project. Not only that, but you consider aspects of the future, like your company is this small today, but after 1 or 2 years, if it is going to grow this big, is your design good enough to handle that big of a volume or transactions or whatever? That's something you want to think about as a principal engineer and work accordingly. So there are things like that. When you are a manager, you cannot really become a manager just like that. You first have to be an individual contributor, like a data scientist, and then slowly you can transition into an engineering manager role. And when you become a manager, typically you will have like 3 or 4 people in your team, and you will oversee their design work and all. You will still do the actual coding work for your machine learning models and all that, even as a manager. That's how it works in the software industry. And when you grow to a senior manager, you have a bigger team, multiple projects to handle simultaneously, working with the leadership and so on. If you become a director, then one whole functional group is what you lead. So for example, like I mentioned here, the platform monetization division, right? You own that division or that monetization group, and you have several projects running in there. And then you focus on, return on your investment and things like that. So there is definitely a very strong career path in this role as well. Like you can become a senior director, vice president, senior vice president, and all. And even I think you can become a chief of artificial intelligence, but that's a very high post. And one who has a PhD in artificial intelligence, he is more likely to become, he or she is more likely to become a chief of AI, proven track record and all. But yes, there is a strong career path available as long as you show passion and you show the quick grasping ability in the artificial intelligence or data science, machine learning fields. So that is the opportunity. Now, when you decide that, yes, I want to build my career in data science, and you take courses and all that, you still have to pass interviews, right? And these interviews, like I mentioned before, are not easy. You have to prepare anywhere from 3 months to 6 months to pass these interviews. There are modules like programming, algorithms, data structures, and so on. As you see here, for programming or coding practice, there is help available. There are two very popular sites called HackerRank and LeetCode. They offer numerous challenges or problems that coding problems that you can practice solving, and they are at different levels, like low difficulty, medium difficulty, high difficulty, things like that. So that's something every single data scientist or a data engineer or a software engineer must do to prepare for interviews. Even there are nowadays companies that offer practicing interviews. So they have their own software engineers who would interview you as a practice, and then they will give you feedback as to how you performed in the interviews. They give you some tips as to how you can improve, and then you can fine tune your preparation and then go for the real interviews and pass those interviews. So yes, there is help available too. And there is a very popular preparation book called Cracking the Coding Interview. It's a very popular book. Every software engineer, at least here in the Bay Area, he or she knows that they have to read this book. So yes, resources are available to for you to help. So this is all pretty much I wanted to talk about today. One last thing, that SVNA, our committee, Kinjal Ben and Sharvari Ben, they all work hard to organize these sessions. In the past and in the future also, they will work hard to organize this. I think their main purpose is twofold. One is to help our Nagar community, and the second is to unite our Nagar community. So I think we should not and we cannot stop short of our appreciations for their efforts. So we should just wholeheartedly appreciate their efforts. So that's all I wanted to say. Thank you, SVNA committee, and thank you to the audience. Feel free to ask any questions. Yeah.
Thank you so much, Atman Brahmachari, for an excellent introduction to what is data science. I knew that you were going to be comprehensive, but I didn't have as much of a grasp to understand how comprehensive you will be. I'm so glad that you were able to bring us the length and breadth and the depth of what this is in such a short introduction. I can see that there are some questions coming in. I wanted to take a minute to introduce today's team to you and to our audience. With us today are SVNA's President Kinjal Buch. Our host team, we have Smith Mehta, we have Shwetang Trivedi, and we have Shivang Vaishnav. All of us are members of the same team, and we bring these programs to you every month. I am going to ask all three of them, Smith, Shwetang Bhai, and Shivang, to jump in with questions. I know that there are some questions that are already on the chat, which Shivang can monitor. but anyone can raise their hand if you look at the reactions, or just open your video and raise your hand, and these three will be able to monitor who they can call upon to ask questions. Let's open it up, guys. What an interesting topic.
Great. Thank you so much, Atman Bhai, for your time and detailed presentation. It was pretty structured, I would say, the word that you used, as typical to a data scientist. So we have several questions. In the meantime, we hear from the audience while they raise their hand. We already have collected a couple of questions related to this particular talk, and I have categorized them so far in two categories. One is data science definition, which was the first portion of the presentation, and the second set of questions are from data science career. So first, let me ask a question which we received from the audience about the data science definition. How does one make sure that the data is of a good quality, or more specifically representative of what is needed for a particular analysis?
Okay. So it depends on what your business need is. It's first of all, it's a total focus on your business need, right? So when you get the data may be or may not be structured. So you have to convert it into structured data. When I say structured data, think of this, that if you have a sentence written by somebody, that is unstructured data. You have to convert it into some structured data such that it is helpful to your business. So you may want to we have the Excel spreadsheets, right? So in that we have columns and all. So that is called structured data, because we divided our information into columns and rows and so on. So that's structured data. When we have structured data, what we do is that for our business, if we need certain types of data, or certain values are good but other values are not good, then from what we know, we first try to filter data. So we say, okay, I need these values in my data. For example, if you are looking for the CT column in a spreadsheet, right, then we say, okay, whether the cities are San Francisco and Los Angeles, or in a given list of cities, is that a valid city or not, right? So we can search like this. So based on what we know, we first apply the filters to understand whether the data is good or not, and then any other data that we get as a separate set. From that also, we try to see whether there is any outlier or not. Outlier in the bad data could be a good piece of data, right? So we go like that, and then accordingly, we can remove unwanted data and then use the required data.
Great, thank you. And one more question from the data science definition or the introduction side was why data science is so critical for business leaders who make business decisions on, let's say, product or a service design, or predict their revenue, or let's say a non-profit business leader who is even thinking of putting metrics related to popularity or reach of its organization.
Repeat the second part of the question, please.
Why is it so critical? Why data science becomes so critical for business leaders who make these business decisions? May it be revenue prediction, or may it be popularity, or their reach into the society, or in respective fields, or in countries, etc. So why is it so critical for?
Correct. Yeah. So as part of data science, one thing that we said was machine learning, through which we make predictions. The second thing is that with data science, whatever historical data that we have collected so far, based on that, data scientists generate metrics, and the metrics that are different granularities. When I say metrics, I will give an example. What is the most popular time for users to browse Facebook? We were looking at the Facebook example, right? So what is the most popular time for users to browse Facebook? We cannot just end with this statement. We have to say a particular region. like on the West Coast, because the time zones are different, right? So we would say, okay, what particular time is most popular on the West Coast for users to browse. Now, and then there could be drilled down further to that, like, okay, now in San Francisco or in Los Angeles, or maybe males versus females, because their activities may be different. So females may be free maybe at 10 p.m. or 9 p.m., but males may be free at 7 p.m. So they want to understand this. And so data science, as part of data science, data analysis and all, these metrics are generated at finer levels or at a higher level and all. And that piece of information gives the business leaders an opportunity to think how to design their strategies for driving their business further. That is why it is so very critical to have data science in their companies, like a presence of data science in their companies. Is that a sufficient answer, or if there is?
Certainly. Thank you so much. Now we have a couple of questions in the data science career section. So first question is, how one should balance between learning mathematical or statistical models versus learning some of the tools that was presented in the presentation?
I would say that your fundamentals need to be strong. So if you are, if you know more about mathematical models and statistical models, as a, as a student, like, if you are in high school or college, then your focus should be on your fundamentals, that is learning those statistical models, mathematical models and all, right? And as you start your career, or maybe you are just about to transition from your academics to your profession, during the transition period, maybe, you can take up some courses to learn about tools and programming languages and platforms and so on. If you are transitioning from some other career to data science, even then, being clear about fundamentals is the most important thing. Now, so I would say that, most popular models, like statistical models in terms of data science, you should have a good grasp on those statistical models that are relevant to data science. I'm not saying every single popular statistical model, but the one that is more relevant to data science and all, or maybe, the one that is particularly related to an industry. Like if you want to work in the finance industry and there, certain models are more popular than other models, then maybe, you prepare those well. Learning tools and all, that's an on-the-go thing. There are so many tools available, so many platforms available that you cannot learn everything. So as you start your career and you take on the tools and platforms and all, you learn them as you go. That's how, but your fundamentals are, if those are not clear, there is a very strong chance that, you will not pass the interviews.
Got it. Thank you so much. That actually answers one of the other questions that was received. So yeah, that was a really precise answer as well. Next question was, how does one differentiate him or herself from others in the data science career, given that there is so much resources available to everyone, lead code, as you mentioned, and the reference books available to prepare for interviews, or even in the long range, if one has to differentiate himself or herself, what are those traits or characteristics or projects maybe?
It's a broad question, but in general, I would say that, don't pay too much attention on differentiating yourself from others. Rather, this field is such that if your fundamentals are very strong and if you demonstrate smartness, even then you don't have to think about, differentiating yourself from others. As long as you demonstrate some smartness and your fundamentals are very strong and you prove that in your interviews, they are going to, approve you. They are going to consider you for hiring. That's my first answer. Now, apart from that, there are other general properties that one should have in order to succeed, which is about, like, good communication, ethical working style. Those are like, common across the board, right? But those are also important. So as long as you demonstrate those principles in your working style, in your talking, conversations and all, yeah, they will consider you ahead of others.
Sure. Sarvari Mashi had a question.
Sure.
Yeah, I wanted to add to that question. When I received that question from the viewer, I believe it was related to the fact that the person is qualified mostly from India. And when they are working here in the US, they want to have an edge over those who have qualified from the US. And they want to demonstrate that they have this edge over others. And so, what is it that they can do to differentiate themselves? This is my understanding.
Thank you for the context.
I see. So first of all, I would like to know, if possible, like, is it their visa situation because of which they want to, be ahead of others, or is it something else?
No, not a visa situation. I'm sure that, for example, when I teach at San Jose State, my students are in direct competition for jobs with Stanford and UC Berkeley, right here in the Bay Area. So my San Jose State students always want to show that they have an edge that is either comparable or better, stronger, sharper than the graduates from these elitist institutions. In the same way, when this person who's qualified and is working here, but qualified from India, they want to show a distinct advantage over the others, so that, so my understanding is, should they look for better projects? Should they do better in certain kinds of situations, so know other tools? My understanding is limited, but yeah,
I got the question now. So one thing is, like, if you are a student, undergrad student or something like that, or you are a master's student, graduate student or what, you should strive to take good projects. That's the first thing, in your college itself. That's the first thing. The second thing is that the internships, you strive to be an intern, not just for the last year of your education, but also, like, first year or second year, whenever you have an opportunity, get those intern opportunities. Because when you work in the real world, you get the real projects on hand, you get to meet with, again, smart people already in the industry and all. So your thinking process, your thought process, gets fine-tuned accordingly. So that's one thing. The third thing is that even in the internships, when possible, choose those projects that are geared towards the career that you want to build. So talking about data science, the internship may be on a somewhat different technology or different area or something like that. For example, you want to be a data scientist, but they may put you as a data engineer. If you are really deeply interested in data science, then you can ask for a data science project, and companies do make adjustments to their plans in order to accommodate your asks. So don't shy away from asking questions or insisting for certain things. Of course, we want to be polite, cannot be very rude, but you can insist on certain things. So that is another thing. And the third thing is, again, if your depth and breadth both are very strong, then you are ahead of others. So for example, if we talk about algorithms, there are certain popular algorithms that most software engineers know. But when it comes to data science, do you know more than that? Do you know other popular or even less popular but interesting algorithms, like very well? You understand? Do you understand very well those algorithms? Yes. Then during your interviews, you can talk about those, and you can, influence the interviewers by sharing your knowledge about those other algorithms as well. This is just an example, but basically, the more the breadth and the more the depth, you are definitely ahead of others.
Excellent. That was a pretty comprehensive answer. Thank you, Atman bhai.
Sure.
One second last question I would ask, because we are reaching 5. But so, what is the uh, advantage of interdisciplinary projects or course programming while in college, undergraduate or master's program? With respect to data science, something like somebody is doing law major with data science minor, or public policy major with artificial intelligence minor. Is there any advantage seen in such kind of a career, course programming?
So if your major is quite different, but your minor is data science, is that what you're talking about?
Yes, yes.
Right. Yeah. So again, if you want to build a career in data science, and is that your question, that, with this type of major and minor, they want to build a data science career or
Correct.
something?
Correct.
They do, right? Yes.
That's correct.
So, yeah. So if their major is drastically different, like you said public relations or something like that, and then the minor is data science, as long as I mentioned in my presentation as well, that as long as your fundamentals are strong, like you understand algebra and calculus reasonably well, I think taking data science as a minor will certainly help you to build your career towards data science. But ultimately, if you see, there are two things. One is with not enough work on data science being a minor subject. If you focus more on your other subject and all, then you can have a career that is a blend of data science and that particular field, but not necessarily purely data science, because data science is a very deep subject, right? So blend in the sense that you get to do other work more, but then you interact with data scientists, you understand their language, you understand the requirements very cleanly, and you can work very closely with them because your understanding of data science is quite good, but not necessarily, as deep as a core data scientist is, right? So you can have a blended career where you work closely with them. Maybe you do some of their work, but not necessarily every single deep data science work task or something like that, right? So that's how you can build a career, which is like, in between like, the two different subjects. But if you really want a pure data science career, then you again have to take courses if those if certain things are missing in your minor. You have to take those courses, work hard, and then apply for relevant jobs.
Got it. That was a very good answer. One last question we have today is, what are the main reasons when many data science projects fail to deliver, and what should be done to drive towards the success?
So the term "they fail to deliver," okay, there could be various reasons. First of all, the failure is not a total failure. I mean, most data science projects are not total failures, but maybe, they are not delivering up to the expectations that the leadership had set for them. And that would be considered their failure. That is one thing. Now, the second thing is those failures are for various reasons. Number one is like, if you haven't understood the real leadership goals. So if there is a gap in understanding between what the leadership thinks about this project and their expectations are, and what you have understood is those two things are different. That is one thing. The second thing is that sometimes your data volume is not enough to train your machines using the models that you write. Sometimes the accuracy of your models that you develop, those are not good as well. So ultimately you try hard, but you don't get the accuracy of predictions good enough. I will give an example of my own company that, we work on store checkout automation. That is, people don't have to wait at the checkout counter. They just grab things and walk out. And my machine learning models will generate receipts, identifying the right items that you have grabbed from the stores and all, right? And we reached an accuracy of some 92%, but taking it from 92 to 95 or 96 has proved to be very hard for various reasons, because there are complex situations that arise, like one person grabs one item and hands over to his wife. and so who, I mean, you know, where, who does the item belong to, the husband or the wife, right? You know, the uncertainties like this. So there are these complex situations or edge cases. If those edge cases are not taken care of well, then your machine learning models will not be able to predict with high accuracy. And if that accuracy is not high, your leadership cannot take it as a successful project. So things like that, there are various reasons that may take place for the failure.
Thank you so much.
Sure.
That was a very comprehensive answer. Edge cases, yes, do make sense, and they do make impactful, make or break the, yeah.
Yes. For example, the store chain that we are working with, they have set this standard called 96% as the acceptable accuracy rate to go GA, meaning, you know, general availability for all customers in the store. And we are so close, but going there, reaching that point is proving hard. And as a result, you know, we are not yet GA in a particular store. So that's if we cannot do that within a short period of time, a reasonable period of time, then that would be our failure.
Okay. I think that's all the questions that we had.
Thank you so much, Shivang, for looking through all those questions. Atman Bhai, I wanted to just tell you that we are live on Zoom right now. However, this entire program is being recorded, and we will be broadcasting it as a recorded program on Facebook, the Facebook example that you showed us, and also on SVNA's YouTube channel. So it will be available to any viewer forever. And we hope that it will generate a lot of statistics from viewers and who will take advantage of all the hard work that you put in. I'm going to ask Kinjal, our president, to say a few words to thank you for coming here and giving us this great information.
Thank you.
Thank you, Sharvari, and thank you, Atman Bhai. This was, I think I'm just talking from my perspective. I'm not a computer person. And you really were able to explain to me what data science actually is and how it is used in the industry today. So I gained that much more knowledge thanks to you. To all those youngsters who were, listening in today, I would say yes. While it may sound overwhelming sometimes, this whole new world of data science that we have. I know that you all can do it because there are so many resources available. Also, I think very important to know that this is such a hot field and such a widely used field. Every company, be it a startup, be it a large company, I think everybody would need either a data scientist or a data engineer in their company for the growth of the company itself, because that's what our world right now is. And so if you are interested, the job opportunities and opportunities for growth are countless. And I think the universities are also recognizing this aspect. And I know that UC Berkeley, just about 4 years ago, they started the bachelor's degree program in data science, and so are many other universities doing that. So it is a relatively very new field for bachelor's programs and all. And that's why I think very critical to get into this program early on while it is still developing. And I think it's a wonderful creative field out there, because I always feel that fields like this are also creative, not just very boring all the time, so you can do wonders with the numbers and the data that you have, like Atman Bhai just showed. So thank you so much for opening all of our minds and eyes to this whole new world that we live in. And I hope more and more people can take advantage of this recorded presentation today. And because I know for sure that a few people called me and they said they could not make it today and they are going to watch it. So very helpful, very comprehensive. So thank you so much, and thank you all the viewers. All of you out there, if you have any suggestion on any future topics that can be covered, please let us know. We'll make every attempt to contact the right people in that field and bring their presentation to you also. So with that, I will end today. And Jai Hatkesh.
Yeah,
Thank you.
Hatkesh, and thank you very much. Thank you so much, everyone.
Yeah.